Here's practice 11.1. There is a very important formula for circles. The circumference of a circle is going to be 2 pi r, r being the radius. So 2 pi times the radius of a circle. Or you could say pi times diameter, because 2 times the radius is the diameter. So either of those will work. Okay. All right, so with that in mind, the radius, we're supposed to find the radius of a circle with a circumference of 42 pi, okay? Now, my circumference formula is 2 pi r. So I can say 2 pi r for this problem is going to equal 42 pi, okay? And then I'm going to try to find the radius, so I'm going to isolate r. So I'm going to divide, I want to get the r by itself, so I'll divide by 2 pi. And then, yeah, the 2 pi's cancel over here, and also the pi's cancel here. Now I've just got 42 over 2, which is 21. And since this is in meters, I know my radius is also going to be in meters, so I do need to put that unit measure in there. Okay? All right, so let's find the circumference of a circle with a radius of 27 feet. Well, 2 pi r is my formula. Now I have something to put in for the radius. So that's going to be 54 pi. So you could say 54 pi feet would be the circumference. That would actually be an exact answer. And if you want a decimal approximation, you could use 3.14 for pi, but you know, our calculators, pretty much any calculator, not any calculator, but many calculators have the pi button programmed in there. On these, for me, it's right there. So if I press second and then that little up arrow key, I get pi. But then if I hit enter, I get that, which is way better than just 3.14. It's not, you know, this goes on forever, but it's a much better approximation then. So I'm going to use 54 pi, like that in my calculator. Or you can multiply the decimal by 54. And then I'm going to round to the nearest hundredth here, so it doesn't say where to round. I'll call that about 169.65 feet. Okay, so either of those would be acceptable, depending on if you want to round or not. Okay, then let's find the circumference of a circle with a diameter of 15 inches. Well, the diameter is going to be twice as big as the radius. So if I know the diameter is 15, I just have to take the radius is going to be 15 divided by 2, which is 7.5. So the radius would be 7.5 inches. Or I guess you could say 15.5 inches. Okay. All right. So next up, find the diameter of a circle with a circumference of 39 centimeters. So, hey, I know the circumference formula. Circumference formula is 2 pi r, or pi times diameter. So since we're looking for the diameter, I'm actually going to use this version. So I'm going to say pi times the diameter is going to equal 39. They tell me it's 39, right? And now if I want to solve this for the diameter, I'm just going to do that. Okay, the pi's will cancel. So if I wanted, again, the exact value, I'd have to write that as 39 over pi. This would be centimeters. Or I could do a decimal approximation. 39 divided by pi. Divided by pi is about 12.41 centimeters. Okay. All right. Moving on. Okay, now we're finding the length of arcs, okay? If I was looking for the measure of arc AB, that would be 60 degrees. But this is not the measure. We're looking for the length, right? So this would be the measure. This is the arc measure. That is different. Okay, not the length. The length is actually part of the circumference. So if you think about this as a pizza, it's how long is that piece of crust? That piece of crust, yeah, it takes 60 degrees out of the circle up. But, you know, you could flatten out the piece of crust and measure it with a ruler, and it's going to be some amount of centimeters. Okay, so I'm looking for part of the circumference. So my arc length is going to be, and I didn't leave myself much space, is going to be part of the circumference. Okay? All right, so in this one, the length of AB, well, how much of the circle am I talking about? Well, I'm talking about 60 degrees out of the 360 degrees. Okay? Part of the circumference, so part of 2 pi r. Okay? Now, I know what the radius is because it's marked here. It's 6. So it's the whole circumference would be 12 pi, but I don't want the whole circumference. I just want really 1/6 of it. So this will reduce to 1/6. So I'm going to take 1/6, what am I doing here? 1/6 of 12 pi. Man, why do I have such trouble writing 12 pi? There it goes. Okay, so if I multiply straight across, you can think about that as 12 pi over 1. So I'll get 12 pi over 6, and that's going to reduce to 2 pi. And I still need my units, which would be centimeters here. Or again, you could do a decimal approximation. Since pi is about 3.14, 2 pi is double that, 6.28 roughly. Okay? So it's part of the circumference. Okay? So same thing here, we're looking for the length of this arc. Part of the circumference here, I'll do this one up here. Here I'm dealing with 150 degrees out of the total 360 degrees, not the whole pizza, but just that much of it. And then I'm using that much of the circumference. So the circumference, I'd find 2 pi r, so 2 pi times 18. Okay, so I'll reduce the fraction if I can, and hey, I can cancel the zeros, right? So I got 15 over 36, and I'm thinking, well, 3 goes into both 15 and 36. So that would be 5/6 then, reduce. No, 5/12, I mean, 5/12. And 2 times 18 is 36. Okay, so now when I multiply this together, got 180 pi over 12, but I can still reduce the 180 over 12. Okay, and not that this would be that difficult, it'd be 90 over 6, and you could go from there, right? But just a quick way to reduce fractions again on one of these calculators. 180 divided by 12. I'm going to reduce this. Oh, it comes out to exactly 15. Okay, but let me choose another one. Let's say I had 62 over, I'll make sure that I get one that can be reduced. So let's say I wanted to reduce this. I'd hit enter, I get a decimal, then I'm going to go to math and fraction. I'll change it back into a fraction. I call this math fracking, and now it's reduced. Okay, but yeah, going back to this one, this comes out to exactly 15 pi. And let's see, 15 pi as a decimal is about 47.12. And we want our units either way, if we're doing exact or decimal approximation. Okay. All right, one more time then, the length of AB. Well, I've got 30 degrees out of the total 360. So 30 out of 360. And then 2 pi r. Okay, this time the 28 is the diameter. So that means the radius would be 14, not 28. So just be careful there. Okay. So let's see, that's going to reduce 3 over 36 reduces to 1. This would reduce to 1/12. 1/12 of 28 pi, which is going to be 28 pi over 12. That's going to reduce, let's see, 14 pi over 6. That would reduce to 7 pi over 3. So 7 pi over 3 feet. Or in a calculator, let's see. 7 pi, divide that by 3, and I get about 7.33. Okay. All right. Last problem. Got this bizarre shape. We're finding the perimeter of this. So let's think what we can get right off the bat. The 4, I believe, is supposed to be this. So if that is 4, and we got to make an assumption here. If we cut this like so, if these sides are congruent, then this last side is going to be congruent as well. You can't. It's not going to work to have just 3 of the sides be. Well, it would. We still are making some assumptions. They don't really give us enough information. The 4 is supposed to be the radius of this half circle over here. This is a half circle, okay? So then I can assume that this is going to be 4 as well. So that means the diameter of that semicircle is 8. So let's assume that this is a square. It looks like it's going to be, okay? So then I've got those 3 parts of the perimeter already. So what I'm going to do then is find this. Okay, now if I think about, let's find the perimeter of a whole circle with a radius of 4. So I do 2 pi r. So that's going to be 8 pi. But hang on, I don't have a whole circle, I only have half of that. So instead of 8 pi, this is going to be 4 pi. Okay, and now I can just add together all those bits to get the total perimeter. 8 plus 8 plus 8 would be 24. Okay, so if you wanted an exact value, that's as good as you could do, be that many millimeters, or you could use calculator. So let's see, 4 pi, I'll add 24 to that, it's going to be about 36.57. That many millimeters. And there we go. Okay, I will see you next time.